Hi, my name is Jenna Ernstine, and I am a sophomore in agricultural communications and journalism, and I'm the environmental option, and that's why I'm taking this class. So I'm really excited to do my torn from the headlines. I'm really interested in geology, so that's where I grabbed my article from. Okay. I got my article from Science Daily. Science Daily is an American news website for science articles. It features articles on a wide variety of science topics. It includes astronomy, computer science, nanotechnology, medicine, psychology, sociology, anthropology, biology, geology, climate change, space, physics, mathematics, chemistry, archaeology, paleontology, and a lot of others. Obviously, all those ology ideas are something that's important for Science Daily and the study of. But this website was founded in 1995 by science writer Dan Hogan. And I guess that's my cue to go to the next page. And it was founded in 1995 by science writer Dan Hogan, who is still the editor today. All the articles on Science Daily are picked from news releases submitted by universities and other research institutions. Some articles are even written by the Science Daily staff. As its name implies, articles are updated to the website daily. However, the website says you can find more articles Monday through Friday than on the weekend. In 2011, a Web Analytics Quantcast listed Science Daily as a top 653 site with over 2 million U.S. citizens visiting it monthly. A recent update to Science Daily website claims that there are now 6 million monthly visitors worldwide and that it generates nearly 20 million page views a month. So I kind of wanted to give you all an idea of how like the Science Daily website, or what the Science Daily website looks like. I'm sorry. So I grabbed I don't know if you can see my mouse or not. Anyways, I grabbed my article from, here we go. Here, let's see. Nope. I'm going to try to get the pen so I can show you. I grabbed my article from Environment because clearly environmental communications, this is where I wanted to get it from. And I kind of wanted to show you what our like subcategories were for environment. So I liked how like geology, global warming, hurricanes, ozone holes, pollution, weather, like those were some of the environmental options there that you could pick from. So, too far. Science Daily boasts over 140 research articles as well as numerous images and news videos covering the science field, like health, technology, and the environment, and all those ologies I stated before. Personally, this isn't my first time utilizing Science Daily. I've used it for a variety of research projects as like colleges progress, as well as in high school they had us do like daily science facts and information, or like news stories about science, and this is where I would always come to get my information. When I began looking for my article, I wanted to look for something that could apply to what we've been discussing in class and something I was interested in, so it'd be more fun to research. So it brought me to an article titled "Scientists Detect Deep Carbon Emissions Associated with Continental Rifting." So what really caught my eye was that this is a first of its kind study, in addition to its ability to quantify deep carbon emissions. I'm kind of a geology buff, so we'll see if I can explain this clearly. Basically, that means that scientists from the University of New Mexico were able to put a number on the carbon emissions coming from the East African Rift. If you're curious about the East African Rift, let me tell you a little bit more about it. Okay. The East African Rift is a tectonic feature of Africa caused by the fracturing of the Earth's crust. So you've probably taken an intro to geology course by now, so you have an idea of what plate tectonics are, and you have an idea of what the Earth's crust is. But the image you see is showing where the rift is located in Africa. This was the best one I could find, so hopefully it gives you a better idea. And I kind of already stated that the East African Rift is a tectonic feature, and it's from the fracturing of the Earth's crust, and it is located near Kenya's southern border. So I'm going to show you an image, and this is a photograph of the eastern branch of the rift, which is located near Kenya's southern border. It highlights the classical geologic structures that are typically associated with the Rift Valley. You can see faults as well as bodies of water in a volcano. However, one of the most interesting features that Rift Valleys have, and this one in particular, and it's just a small picture, but it shows the almost parallel fault lines. And let's go here and see if I can, oopsies. I'm not very good at this. You can kind of see the fault lines are just going kind of, it says, when I was looking it up, that it's from north to south, which makes sense. So like our little compass there. The prominence of this fault line extends beyond this article. In other places along the rift system, there are more volcanoes, some of which you might know, like Mount Kilimanjaro or Mount Kenya. So let's go to the next slide. The main reason this study is taking place is in an effort to understand the carbon emissions from the Earth's interior and how it's affecting the atmosphere. So we are kind of looking at those coveted words of global warming and climate change. So after listening to Dr. Rice's presentation about global climate change, as well as previous knowledge, we have a better understanding that the global warming and climate change trend is a lot from human expansion in addition to just natural causes. But the human expansion is affecting the greenhouse effect. So certain gases in the atmosphere block the heat from escaping. These gases are what are adding to the greenhouse effect. And these gases are water, vapor, methane, nitrous oxide, and carbon dioxide. So we're really going to look at carbon dioxide emissions. So carbon dioxide, although it's a minor part of the atmosphere, it's rather important as it's released through natural processes such as respiration and volcanic eruptions, and also through human activities, and some of which we know from like major news sites are like deforestation and land use changes and the burning of fossil fuels, which has become a lot more prominent like after the Industrial Revolution. And the gases released from the fault systems in active volcanoes are poorly constrained and to date have been largely unmeasured. So that's kind of what they're looking at more in this study. So the National Science Foundation Tectonics Program, which is a part of the University of New Mexico, is working to better quantify or put a number to the global emissions of CO2 from the Earth's interior. I'm going to head to the next slide. Okay. The research is to show that CO2 gases are being emitted from non-volcanic and continental rift regions as well as through volcanic activity. The East African Rift is the world's largest active continental rift where both volcanoes and large lakes emit CO2. And if we go back real quick, to this image, we can see that there are lakes and there is a volcano as well as our plate tectonic lines. To measure the amount of CO2, the research group at the University of New Mexico used and I quote this, an AGCOM CO2 gas analyzer with a cylindrical accumulation chamber. So basically what they did is they took samples of gas and they put them into a chamber and diverted them into individual glass vials. They then took these vials to laboratories at the University of New Mexico, and they did a little bit of gas chemistry and carbon isotope analysis, and that's where they really found out what the emissions were from this rift system. So some of the gas samples at the base of the rift, so like at the southernmost area, showed higher levels of CO2, and that explains that the faults act as pathways, helping the CO2, which is located deep into the earth, to escape. So kind of think it like if you've ever had an ant farm, you all the little tunnels underneath the main surface, like where the sand is that the ants dig their tunnels, think of those as the pathways or the faults within the earth that are allowing the CO2 to escape. So you can just picture the little ants crawling through their tunnels, and they're the CO2 escaping from the bottom or from the lower part of the earth. So research found that 4 megatons, which is 4 million tons of CO2 is released each year from the northern basin of the Earth, specifically the upper crust of the mantle. So this is 1 ton of CO2. Now, try 4 million of these tons, and this is just released from the northern basin of the Earth. It also comes from the upper crust of the mantle because that's where it travels through the crustal bodies, and it uses magma to travel through the crustal bodies. So the University of New Mexico's findings suggest that an entire branch of the Eastern African Rift system produces 71 million tons of CO2 emissions a year. And remember, this is only one rift system. There are other rift systems. We have rift systems in our oceans and or along our oceanic plates. So this is just one, and that is 71 million tons, which is basically 71 million of those balls. And that's it. That's it in that rift system. I mean, there's plenty more. So on human timescales, continental rifting is rather slow spreading at about 1 millimeter a year. However, on geologic timescales, rifting can be really catastrophic, and it can be a continental breaking event. So widespread rifting and continental breakup can produce massive long-term CO2 emissions, which does heat up the atmosphere and kind of relates back to our greenhouse gas that we talked about at the beginning. The researchers plan to continue taking gas samples to have a better idea of how deeply CO2 is emitted from natural systems like this rift. The scientists that participated in this research talk about how fault zones have never really been paid attention to, and no one's really looked at the global impact from the CO2 emissions at fault zones specifically. So it's really been underestimated the CO2 emissions at the fault zones have really been underestimated since no one has been able to quantify how much CO2 is being emitted. So now we have a better idea of how much and where the CO2 is coming from, especially in more non-volcanic areas, such as like the lower areas of the rift system. So to relate this back to the book, I think it can be related really well to chapter 1 and the study and practice of environmental communication. So there's a little section there, and it talks about under scientists and scientific discourse. Cox talks about climate change and scientific reports leading to other important investigations and debate about problems affecting human health and the Earth's biodiversity. So it really does relate well because this is one study that we're looking at rifts. So now people are going to probably start looking at other geological features and maybe not like pay as much attention to volcanoes where we really thought a lot of the CO2 gas was coming from, but looking at more rift systems and like other areas where our plates aren't exactly aligned and where gases can be emitted. Reading this article definitely put a picture of a huge crack spewing gas into my mind. However, that's not the case, but it kind of relates back to chapter, I think, 3, and how like an imagery as well as how images like polar bears and the ice caps like really puts a negative effect or a negative image in our mind. So this kind of, although it's not a picture you see, the image that your mind creates really has an impact on how you believe something's being communicated to you. Also in chapter 3, Cox talks about portraying nature. So I want to ask you, do you think people will see this fault as just a large CO2 emission opportunity for the Earth? So do you think people will see it as a really bad way for CO2 to escape, or like kind of like the big gas going out of this crack in the Earth? Or do you think they'll just see it as something natural? So I have a few questions for you to think about. Do you think that with the new information we have on CO2 emissions from rifts and other geological features that people will begin to notice the effects of the emission, or do you think they'll just go along and not really think about it too much? My other question for you is, do you think that people will be less concerned about humanity's CO2 emissions now that we can attribute a bulk of the emissions to a more natural cause? So do you think people will not be as concerned with driving cars, or it's really not horrible CO2 emissions, but big industry and the emissions from that? So those are just a couple things to think about. I really hope you enjoyed learning a little bit about this rift system and how we are beginning to measure or quantify is the better word, CO2 emissions. But thank you.